what does it really mean for an AI to think? Today, we're diving deep into the architecture of modern .NET hiring. Cloud-native .NET demands engineers who design distributed systems, not just write code. Microservices, event-driven architectures, and .NET 8's native AOT require architectural thinking. At interview stage, this framework establishes the standard for evaluating system design capability within the .NET ecosystem. Hiring decisions now carry strategic weight, but here's where it gets interesting. The signal gap, standard .NET interviews, test trivia, GC modes, async internals, or algorithmic puzzles, neither reveals how a candidate reasons about data partitioning, service boundaries, or resilience. The outcome hires strong on syntax, weak on architecture. Real system design skill remains invisible. So what's the real problem? Let's talk about root cause. No shared evaluation model exists for .NET system design. Generic rubrics ignore the ecosystem's unique primitives, Orlan virtual actors, MediatR pipelines, poly policies, YARP, MassTransit sagas. Interviewers improvise, candidates prepare without structure. The gap widens with each .NET release. This raises a critical question. Breakthrough, the .NET System Design Canvas, a layered assessment framework purpose-built for the .NET landscape. 5 dimensions evaluate design decisions end-to-end. Each layer maps directly to .NET technologies and design patterns. The canvas converts architectural reasoning into observable, comparable signal. Now let's zoom in on system architecture of the canvas. Business domain data topology communication, fabric, resilient strategy deployment model. Each layer has scoring criteria tied to .NET primitives. Dependency between layers reveal cross-cutting concerns like observability, security, and cost. The canvas functions as a shared mental model for interviewer and candidate. Here's something most people overlook. Condominant breakdown. Design diamonds. Domain. Aggregate boundaries, domain events, MediatR, minimal APIs, data EF core, Cosmos DB, event sourcing, outbox pattern, SQL server sharding, communication, gRPC, SignalR, MassTransit, N-Service Bus, Dapper, Pub, Sub, resilience, poly, circuit breakers, bulkheads, timeouts, retry storms, prevention, deployment, AKS, .NET Aspire, Azure Container Apps, infrastructure as code considerations. Think about this for a second. Workflow. The 4-phase interview loop. Phase 1, scoping. Clarify functional and non-functional requirements. Latency, throughput, consistency. Phase 2, high-level design. C4 container diagram. Service boundaries, data flows. Phase 3, deep dive. Zoom into one dimension, e.g., messaging resilience with MassTransit and Poly. Phase 4, trade-off analysis, consistency versus availability, sync versus async, cost versus performance. Each phase builds on the last, and this is where things get complex. Validated architectural competencies, the canvas tests decomposition, technology justification, scaling strategies, and failure mode reasoning. It exposes knowledge of .NET specific concurrency, serialization, and middleware pipelines. Candidates demonstrate real on-the-job design speed, but here's where it gets interesting. Before and after, hiring signal, old approach, fragmented trivia, no system view, canvas approach, coherent architecture signal, ecosystem depth, clear decision rationale. Interviewers reach consensus faster, false positives drop measurably. So what's the real problem? Let's talk about impact metrics. Teams report 40% reduction in architect mishires,